Most of the programs that you write in processing will be just chock full of numbers. Some of those numbers will describe where things are, others will describe where they should go on the screen, some numbers describe colors, and so on. Because of this, processing offers us lots of ways to manipulate those numbers to make them more useful to us. In addition to lerp and map, both of which we've already seen, processing offers us a grab bag of other useful little functions that manipulate numbers. Most of these routines take one number as an input, and they do something to it and give us another number as an output. Let's take a look at them in no particular order, but I'll start with the simpler ones. The function abs is pronounced abs. It stands for absolute value. This takes in a floating point number, here I'm representing it by x, and it gives us back a new floating point number. The easiest way to describe this is with this little conditional. In effect, it says if x is less than 0, then return minus x. Otherwise, return x. In words, if we hand abs a number and that number is positive, we just get back the number we gave it. If the number is negative, we get back the positive version. The next routine we'll look at is called int, and all this does is throw away the fractional part of the input value. So if we hand it 3.7, we get back 3. The function floor does something very similar. It rounds x down. That is, it finds the first integer to the left of x on the number line. The name floor is meant to remind us that we're going down, because the floor is usually beneath us. What if we want to round x up? You won't be surprised to learn that function is called ceil, which is short for ceiling, and this just rounds that number up to the next integer. Finally, what if you want to round your number to the nearest integer, not necessarily up or down, just whichever integer is closest? That's what round does. It does the normal rounding of x. So if we hand round the number 4.2, we'll get back 4. But if we hand it 4.9, we'll get back 5. Those are the utilities that take in just one argument. Now, let's look at utilities that take 2 or even 3 arguments. The function min is short for minimum. It takes 2 arguments, which can be ints or floats, and it gives us back the minimum, or the smaller of the two. We could write it this way: if x is less than y, we get back x, otherwise y. No surprise then that there's another function called max. It returns the maximum of x and y. So if x is greater than y, we get back x, otherwise y. Here's a routine that takes 3 values. Constrain takes a value v and 2 more numbers a and b. Here's a little picture to show you what this does. If v is between a and b, well, we just get back v. But if v is less than a, we get back a. And if v is greater than b, we get back b. So no matter what the value of v is, we know we're going to get back a number that is never less than a and never greater than b. Finally, we have a couple of little math routines. If you want to find the square root of a number, you can call this function sqrt, and that returns the square root of it. If you want to square a number or multiply it by itself, you can call sq. This is really just a shorthand for x times x. You might wonder, what's the value of this? Well, if x is a long variable name, this can save you a little bit of typing. Let's see these in action. In this figure, the number line is in the middle. Our input value is the dark brown little circle, and the output value is the bigger circle around it. Right now, we're finding the absolute value of the input. So as I grab the input and move it around with my mouse, we get back the absolute value. So I'm just dragging the thing to the right, and of course the absolute value of any positive number is just that positive number. What if I take the input negative? The output is the value of the input, but without the minus sign. So this is what abs does. It just takes a number, and if the number is positive, we get back that number. If the number is negative, we get back that value, but positive instead. Now let's take a look at the next routine, constrain. Here I'm going to constrain the input between -3 and 2. So as I move the input between -3 and 2, the output moves with me. But if I move the input beyond 2, the output clamps at 2. It just won't go beyond it. And if I take the input below, say, -3, bam, we clamp at -3 as well. So if my value is less than the second argument to constrain, or if it's greater than the third, we get the endpoints. Otherwise, we get a value between the second and third arguments. Integer, or int, just throws away the floating point value. So here I'm handing it 0.6. It says, well, what happens if I throw away 0.6? We get back 0. Here I'll take my input and I'll move it up a little bit, 0.7, 0.8, 0.9, and as soon as I hit 1, bam, the output jumps. Now I'll go up 1.1, 1.2, 1.3, and of course I'm rounding here, so it takes a little moment for it to catch up with me. 1.9, and as soon as I hit 2, it jumps. So we always get the integer to the left of the dot. What if we move the dot down into the negative numbers? Well, the integer value of minus something is still going to be 0 because we're just throwing away the fractional part. The integer value of minus 1.3, that's just minus 1.0. So let's take the number down to say minus 3 point something. Still, the integer value is just minus 3. So you can think of this as taking the input value and pushing it towards 0, either left or right, depending on whether the input is positive or negative, and it gives us the first integer it hits, pushing back towards 0. In other words, just throw away the fractional part. Floor does something similar, but it always gives us the integer to the left. So whenever the number is positive, floor is doing the same thing that int did. It just throws away the fraction. So let's go down to, say, 2.5, and the floor of that is just 2.0. But if I go negative, let's say minus 0.5, our output is minus 1.0. Again, it always takes our input and pushes it left until it finds the first integer, and that's the value we get back. So floor always gives us an integer that is less than, that is to the left, of the input. Well, let's try ceil, short for ceiling. And of course, this does just the opposite. It pushes the number towards the right. So if I take the ceiling of 1.5, I get 2. And the ceiling of minus 0.6 is 0. It just pushes the input to the right until it hits an integer. So that's ceiling. Here's rounding. Now I'm around 1.0, and you can see that the rounded value of 0.7 is 1, and the rounded value of 1.1 or 1.2 or 1.3 is 1. But as soon as I get beyond 1.5, boop, it jumps over to 2. So everything between 1.5 and 2.5 is going to round to 2. But as soon as I get to 2.6, that's going to round up to 3. And the same behavior down here in the negatives. So as I'm in the neighborhood of minus 1, the rounded value itself is minus 1. Here's square root. Right now, the input value is negative, and there just is no such thing as the square root of a negative number, not in the sorts of numbers that we're used to. So in fact, this is not even a legal function call. Typically, if you ever plan to hand a number to square root, you first will test it to make sure it's positive. So let's go ahead and make it positive. And here we are. We're getting back the square root. And sometimes if you're doing some complicated geometry, this can be useful. We saw that there's also SQ, which just multiplies the number times itself. And that causes the number to go up very fast. And that works both positive and negative. Multiplying a negative number times itself gives us a positive number. So here's an interesting thing about SQ. As we make our way from 0 to 1, the output lags behind us. Notice that the big dot is to the left of the input dot. But as soon as we hit 1, the output starts running away from us and it becomes more and more positive, faster and faster and faster. Here they are all in one place. Our basic one-argument functions are in the upper left. Our basic 2 or 3 argument functions are in the upper right, and the 2 slightly weirdo math functions, each of which takes 1 argument, are on the bottom. The way to think about these things is that they're sort of little tools for helping us to shape numbers. There's no single precise use for any of these. They're here because much of our thinking and processing is about making patterns out of using numbers. So if we can make interesting changes to the numbers, we can make interesting visual patterns. These functions are sort of multi-purpose tools to help us take numbers and make patterns out of them. So keep these in the back of your mind, and you'll find over time, as you plan and develop your own sketches that use patterns of numbers for everything from animation to interaction, these little routines will come in handy to help you make those patterns.